Good afternoon, class. We are looking at the final exam review part one. The final exam is comprehensive and it's going to cover from 1.6 to 5.4. There is a pledge, as always, per exam. I expect you to follow and honor that. I pledge on my honor that I will neither give nor receive unauthorized assistance, so on and so forth. And so when you take the exam, you take the exam on your own. Various differentiation formulas we need to be comfortable with, including the concept of a linearization, delta y versus dy, logarithmic properties from the general form to common to natural logs, change of base formula, all of the above. Basic integration formulas ending with FTCs, fundamental theorem of calculus, and substitution rule. And now, as I mentioned, we're going to go over the a few examples pretty fast. This is the exam review. These are the questions you've seen already. So anytime you want to differentiate where the numerator is a number, you bring this one up, you raise it to the power of 1/2, bring it up, becomes negative, and then you follow the extended power rule. 4 times negative 1/2 times the parenthesis to the power of negative 1/2 minus 1, and the derivative of the inside is 2x. The product of these two is negative 2, with this becomes negative 4x. This goes down and takes the power of positive 3/2, or we can write it in this format with the square root format. Y equals 2x plus 3 over x minus 8 to the power of 5. We follow the extended power rule, 5. The function to the power of 4, and then the derivative of the inside by the quotient rule. F prime is 2 times g, which is x minus 8, minus g prime is 1 times f, which is 2x plus 3, and over g squared, the bottom square. This is the extent of the calculus. We are done. So we are going to distribute 2x minus 16 minus 2x minus 3, and 2x cancels out the negative 2x. These two add up to negative 90. I'm going to rewrite this so it becomes clear that the top has exponent 4, so does the bottom. And the bottom is x minus 8 to the power of 4 plus 2, which makes it 6. And the top is 5 times negative 19, negative 95 times 2x plus 3 to the power of 4, and we are done. Implicit differentiation for x squared y is the product of 4x squared and y, and therefore we need the product rule on that. So having said that, we're going to write this as fg, and we're going to use f prime g plus g prime f. So the derivative of 4x squared is 8x times y, plus the derivative of y is y prime times 4x squared. 2y squared, the extended power rule, or in this format, the derivative of y to the power of n is ny to the power of n minus 1 y prime. So that becomes 4y, y prime is a number, gives you 0. We keep these two, and we factor out the 4y prime out, and we take 8xy to the right, make it negative. We divide by everything sitting next to y prime, which means 4 times x squared plus 8. The final answer is negative 2xy over x squared plus y. When you differentiate sinusoidal functions in general, trigonometric functions, of course, the derivative of cosine is negative sine, and cosine of gx gives you negative sine of gx g prime. But one easy way to understand this, just read cosine and pause, the answer is negative sine. However, we can't write any trigonometric functions without its argument. We use the same argument. By the chain rule, we need the derivative of the argument, which is 12t cubed We put that in front, and y prime is negative 12t cubed, sine of 3t to the power of 4. And that is the final answer, everybody. Let's look at the application problem. More specifically, related rates. A small rock is dropped into a lake. Circular ripples spread over the surface, with the radius of each circle increasing at the rate of 3/2 feet per second. Find the rate at which the area of a circle is changing when the radius is 4 feet. And of course, this is a circular shape. From the center to the circle, the distance is called the radius. If you go both ways, it's 2 times the radius, and it's called the diameter. If you go around it, the circumference is 2 pi r, and the area is pi r squared. In this case, we need the area, pi r squared. It's increasing at this rate. What? The radius. That means the r. dt is 3/2 feet per second. What do we want? The a dt. At what point? When radius is 4 feet. So this is translation into math of the given question. So you want to differentiate pi r squared, or in other words, you want to find the a dt, and you start with pi as a multiplier, as a coefficient, and you don't do anything to that. You work on r squared, you get 2r dr dt, you rewrite it. Replace the r, replace the dr dt. And you get 12 pi units of the area over the units of time, 12 pi square feet per second. This is an exact answer. You always keep it as an exact. And if they ask you, then you go with the decimal representation with however many decimals they ask you. Find the y dt for this equation, 5x plus y to the power of 4 minus x equals 6. And the moment you see the y dt, you recognize t as the independent variable. Therefore, this becomes, using the extended power rule, 4 times the same thing to the power of 3. Now, the derivative of the inside, g prime of x in essence, this is 5 dx dt plus dy dt minus x is dx dt, and any number results in 0. And this is it. We're done with calculus. We have a choice. We can solve for dy dt or just plug in. We are going to plug in. 10 minus 9 is 1. 1 cubed remains. This is 15. So we get 4 times 15 plus dy dt minus 3, and we distribute. We get 60 plus 4 dy dt minus 3 equal to 0. 60 and minus 3 is 57. Moves becomes negative, and divide by 4, and dy dt becomes minus 57 over 4. Another application problem, and again, more specifically related rates. A 20-foot ladder leans against the building. The base of the ladder slips away at the rate of 2 feet per minute. Find the rate of change of the height of the ladder when the base is 12 feet from the building. You have to have the drawing. You have to define your variables. So here's the ladder, here's the building, here's the 12 feet that they're talking about. This is moving this way, this is coming down, and we're going to define the base as x, the height as y. As it moves this way, it creates the speed dx dt equals 2 feet per minute. As it comes down, creates dy dt that is missing, and we are looking for it. Of course, the ladder is fixed at 20 feet. So we are going to write all of this. We're going to write dx dt is 2 feet per minute. Dy dt is missing. At which point we are interested in finding dy dt? At a specific point when x is 12 feet. Pythagorean theorem, a squared plus b squared equals c squared becomes x squared plus y squared equals 20 squared. Pythagorean theorem. Differentiation, 2x dx dt plus 2y dy dt equal to 0. You notice you have everything except y is missing, but at the point that x is 12, we can plug in. We get 12 squared plus y squared is 20 squared. This is 144. This is 400. Subtract. We get 256 and we get 16 feet. We plug in 2 times 2 times 2 is 48, 2 times 16 is 32. We're going to move the 48 becomes negative. We divide both sides by coefficient of dy dt, which is 32. They're both divisible by 16. And we get negative 3/2 feet per minute. Obviously, x is increasing. The x dt is positive. Y is decreasing. Dy dt must be negative. And it is. If you want to find the limit, you plug in. What happens? You get to a number. You're done. You get to 0 over any number other than 0, the answer is 0. You get to a number over 0, that's either infinity or negative infinity. And most of the time in calculus, we end up with indeterminate forms of 0 over 0, infinity over infinity, or infinity minus infinity. So what happens here if we plug in, I hope you realize this is infinity over infinity. The technique is whenever we have a fractional format, in this case, more specifically the rational format, we divide by highest degree term in the denominator, which is x squared in this case, because it's approaching infinity, we divide by x squared. So it simplifies to 2 plus 8x over 1 minus 16 x squared. As you take the limit, this goes to 0, this goes to 0, the answer is 2. However, it's really a good practice to deal with the simplified version. You factor the numerator, you clearly can see 2x comes out, and the bottom is the product of a plus b, a minus b, so x plus 4x minus 4. Therefore, we drop the common factor of x plus 4. Now, if we work on that, then we have to divide by highest degree term in the denominator. This time is x, and it doesn't matter. It gives you really the same. This becomes 2, this becomes 1, this becomes minus 4 over x, and this goes to 0 as x goes to infinity, so the answer is the same. However, in this case, when you plug in, you get 0 over 0, and therefore it can't work unless you work with the factor form. In other words, the methodology to fix the problem is to use the factor. And because x is approaching minus 4, it must have a factor of x plus 4. It does, and it simplifies. And now if you plug in minus 4, you get 2 times minus 4 minus 8. Minus 4 minus 4 is minus 8. And the ratio is positive 1. What about here? In this case, if you don't, the numerator becomes 0, the denominator becomes negative 16, and you get 0, and that's fine. If you work with the factored format, you get 0 over minus 4, and either way you end up with 0. Really doesn't make much of a difference. However, how do we deal with this guy? If you plug in 4, what happens? The denominator becomes 0, but it is easier to work with the factored form. So in both cases, we're going to work with the factor. Notice in both cases that the numerator essentially is 8. And of course, if you look at 8 from the left and from the right, it's both positive. In other words, every number from both sides have the same sign. Negative is negative, positive is negative. A positive is, if negative is negative on both sides, positive is positive on both sides. So over here, as x approaches 4 from the left, the numerator is like 7.9999 because 2 times 3.999. This one is like 8.0001. Makes really no difference. But what is the difference? The denominator. Although the denominator is 0, remember 0 is the only number. Its right side is positive. Its left side is negative. So if we look at 4 from the left, such as 3.9, we get negative 0.1. So it's 8 over 0 from the left. And although it's infinity, the sign tells us positive over negative is negative infinity. But over here, if you go with 4 from the right, such as example 4.1 minus 4, you get positive 0.1. And now infinity is positive because it's positive over positive is positive. So that's the difference between the two. So a recap for these two. When the denominator is 0, it makes a difference whether it's 0 from the right or left. Okay. If it's in the numerator, it makes no difference. Okay. Even if you have a 0 in the numerator, it doesn't matter. Okay. But if you have any other, it doesn't matter either, because if it's positive, both sides is positive. If it's negative, both sides is negative. Now, to find the limits, we are going to plug in, and we notice e to the power minus t. When we look at e to the power minus m is 1 over e to the power of m. So e to the power minus t is 1 over e to the power of t. And if you plug in infinity, e to the power of infinity is infinity. 1 over that is 0. And therefore, the answer is 12 over 4, which is 3. But in this case, because e is to the power of t, when you plug in e to the power of infinity is infinity. 3 times infinity is infinity, plus 4 infinity makes no difference. Any number over infinity is 0. Or for that matter, any number over negative infinity is 0. When we look at part C, I hope we recognize that they are identical to part A. In part A, t approaches infinity. In this case, t approaches negative infinity. And because it's e to the power of t, it's e to the power minus infinity, and it becomes 0 just like this. So 12 over 4 is the final answer, just as we did in the previous. And this one, you just plug in, and you know e to the power of 0 is 1, so the denominator is 4 plus 3, 7. Let's switch gear and do the differentiation. And again, reminding everybody that you bring this one up and you make it to the power of -1. Therefore, you don't have to use the quotient rule. It makes no sense to do so. So the answer is 12 times -1 times the same thing to the power of -1, which is -2, times the derivative of the inside. So I'm looking at the extended power rule, g prime of x. The derivative of the inside is 3 to the power of t. And so 12 and -1 and 3 to the power of t is -36 e to the power of t. This one remains intact, goes down, and the exponent changes to +2. All right, so we're dealing with the limits, and as soon as we plug in, we notice this becomes 0 over 0. And when you get 0 over 0, it is the 0 in the denominator, which is a problem. X approaching 5 indicates there has to be a factor of x minus 5, and it does just factor the x out, and this is a squared minus b squared. And so x minus 5 from the top and the bottom cancel each other. And now if I plug in, I get 5 and 5, 10 over 5, which is 2. For part B, if you plug in, as x approaches -4, you get 0 over 0. And because this is a complex fraction, the technique is LCD, which is multiply and divide by 4x. The denominator doesn't change. It's a product of x plus 4 and 4x. The numerator, when you multiply these two, you get x. When you multiply these two, you get plus 4. And we can cancel these two. The numerator is 1. We plug in, we get -1 over 60. In this case, it's 0 over 0. I hope you realize that. And therefore, Because you're dealing with a square root, you are going to look at the conjugate. The conjugate of a minus b is a plus b. And so the conjugate of the numerator is itself change the minus 1 to plus 1. So you're going to multiply and divide by it. And the reason you do so, because this expression must be 1, and it is. The numerator becomes the square root of 1 plus h, quantity squared minus 1. So that comes out, becomes 1 plus h, and then minus 1. 1 and minus 1 cancel each other. Then h cancels out the h, and we get 1 in the numerator. If I plug in 0, the square root of 1 becomes 1. 1 and 1 is 2. The final answer is 1/2. What about this one? I want to take the limit. Now, this is a rational function, yet it's a fractional format. As you recall, you plug in, and e to the power of infinity is infinity, minus e to the power of infinity is infinity times minus 3 becomes negative. So you have infinity over negative infinity, which is again indeterminate form. And we said when t is approaching infinity or x approaching infinity, the technique for a rational expression is to divide by highest degree term in the denominator. In this case, you divide by highest value because it's not a polynomial in the denominator. So you divide everything by e to the power of t, and you simplify. So this becomes 1, this becomes minus 3. And so this, as t approaches infinity, this guy goes to 0. This guy goes to 0. You get positive 1 over negative 3, which is negative 1/3. We want to differentiate, and we notice is the product of e to the power of x, 2x and ln x, and we say, okay, we are dealing with fg, and therefore we are going to use the product rule, f prime g plus g prime f. E to the power of 2x is itself, when you differentiate, times 2, and then times g ln x, plus g prime is 1 over x times f, which is e to the power of 2x. Notice between the two, e to the power of 2x is in common. If you take it out, this gives you 2 ln x, and this gives you 1 over x, and you're done. Log, you want to differentiate. The first step, can I decompose the log? The answer is no. So you just write its reciprocal 1 over x squared plus 1 by the chain rule, the derivative of the argument 2x. Then you look at the base. If the base is e, you're done. It is not 1 over ln b, 1 over ln 5. And then you rewrite it as 2x over x squared plus 1 times ln 5. You keep the x squared plus 1 on the left side because you don't want it to think if you put it here, one may think that it's part of the argument, which is not. Ln of 2x over 2x plus 1, you use the quotient rule number 6 first, and again, you can do it in one shot, and it becomes ln of 2x minus ln of 2x plus 1, and ln of 2x is, again, using the product rule, ln of 2 plus ln of x. Now, ln 2 is a number, and therefore, the answer is 0. ln x is 1 over x minus 1 over 2x plus 1 times its derivative, which is 2. Now, obviously, the LCD, and we're done with calculus. LCD is x times 2x plus 1. So 1 times 2x plus 1 minus 2 times x. 2x and minus 2x cancel each other. The numerator is 1. So 1 over x times 2x plus 1 is the final answer. Find an equation of a tangent line to the graph of this function. You need two things. You need the slope, and you need the pair x comma y. The slope, you have to differentiate. You get 2x minus 3, which is not the slope. So what is the slope? When you plug in 2 times 4 8 minus 3 equals 5. Now it becomes the slope. Now you need a point, plug in 4 into the function. 4 squared minus 3 times 4 minus 1 becomes 3. And now you use the point slope. Y minus y1, that means y minus 3, equals m5 times x minus x of 1, that means x minus 4. And y becomes 5x minus 17 when we put it in slope intercept format. A doctor prescribes a 300 milligram drug to be taken every 12 hours. Just before each tablet is taken, 40% of the previous amount of the drug remains in the body. So write the expression for Q sub n plus 1 in terms of Q sub n and the rest of it. Now, right away, we should recognize that we have to write the given. 12 hours plays an important part, but it doesn't enter any of the equations. So 300 milligrams is the amount of constant or lowercase c. 40% is what remains is R, or just 0.4. Now, B sub 0 equals A, we're going to say Q sub 0 equals A is 0 because in the case of patients, this is always 0 unless otherwise mentioned. And so if I want to come up with Q sub n plus 1, I'm going to write B sub n plus 1, and I'm going to change the B to Q. So B changes to Q. Now, all I have to do, refer back to what I wrote as the given. Replace the R with 0.4, lowercase c with 300, and I'm done. To find Q sub n, I'm going to write B sub n and change B to Q. And again, I'm going to go back to the given. Replace Q sub 0 with 0. R with 0.4 and lowercase c with 300. When I do that, obviously this goes to 0. This is 0.6. I put it under 300, becomes 3,000 over 6 or 500. So you want the fifth tablet, put n equals 5 here, put it into a calculator, evaluate it, you get 494.88 milligrams. You want the limit, take the limit of this expression. When you do that, I hope you remember that this one is between -1 and 1 goes to 0. So the answer is 500 milligrams, which means it is safe. This is the amount they have calculated that it is safe for the patient if even the patient keeps receiving the same amount of medication forever and ever. Of course, it won't happen, but just in case, that is safe. That's what they have found out through their calculations. All right, the function is given. We want to differentiate and integrate. To differentiate, dealing with the exponential, differentiation and integration is the same thing. In the case of a differentiation, you multiply by -2. In other words, the same thing times -0.2. But in the case of integration, you're going to divide by it. And of course, minus sine x, you differentiate, you get minus cosine x. You multiply these two and you get -0.8 e to the power of -0.2x minus cosine x. To integrate this, we're going to multiply it by dx first. It's important to know the dx must be there. And as I mentioned, for integration, we're going to divide by -0.2. And of course, now the integral of minus sine x is plus cosine x and a constant. And this is 4d over -2, which makes it -2. Now, to make this into an initial value problem, all you have to come up with a pair. In this case, f of 0 equals 20. That means the pair 0, 20. Which means replace the x with 0 and f of x or y with 20. When we do that, This is 1, we get minus 20, plus 1, plus the constant is 20, C must be 39, replace it. And so what we are dealing with here is a general solution. That means infinitely many solutions, a family of functions. This is a particular solution. So with the help of one pair, infinitely many solutions, which is the general solution, comes down to only one solution or one of those functions. So general solution, particular solution. X plus 1 divided by square root of x dx. When we integrate that, we are going to make up two fractions. And we're going to change the square root of x to x to the power 1/2. The quotient rule of exponents says this is x to the power 1 minus 1/2, which makes it x to the power 1/2. And this is x to the power negative 1/2. And now it's ready for the power rule. So this is 1 over 1/2 plus 1, x to the power 1/2 plus 1. This one is 1 over negative 1/2 plus 1, x to the power of negative 1/2 plus 1. 1/2 plus 1 is 3/2. Negative 1/2 plus 1 is 1/2. Division by those, that means the reciprocal. This is 2/3. This is 2, and we get 2/3 x to the power of 3/2 plus 2 x to the power of 1/2 plus the c. And if you want, you can write this as 2 square root of x. And you can write this 2 square root of x cubed over 3. If you want to write it in that format, it's not that big of a deal here. We want to deal with the substitution, reminding everybody, here's the tip. Look for a function u equals g of x anywhere in the integrand. And its derivative du or g prime multiplied by dx. You're dealing with a polynomial x squared plus 5 and a polynomial 2x. X squared plus 5 is more complicated, which makes it a choice of u. If I differentiate this, I get 2x. That means du dx is 2x. And that means du is 2x dx. To become clear what we are dealing with, we are going to move things around. By moving 2x next to dx, it becomes clear that this is u. This is du. And therefore, we are dealing with u to the power of 30 du. And that follows the power rule, 1 over 31, u to the power of 31 and a constant, where u is x squared plus 5. Reverse substitution, give us the final answer, 1 over 31, x squared plus 5 to the power of 31, plus a constant. It's important, again, when you have substitution, first and foremost, define your u and then come up with du. Any fractional format, the very first step is to simplify and put it in lowest term if possible. This is simply a fractional format because this is a transcendental function, but this is more specifically a rational function. Makes no difference. This can't be simplified. The denominator is a choice of u. Its derivative is e to the power of t. Therefore, du is e to the power of t dt. So you are going to write the integral of e to the power of t dt over 5 plus e to the power of t, because you're going to put that at top. So clearly the top is du, the bottom is u, and that follows the result for which is a natural log. And of course, u, the reverse substitution, you get natural log of absolute value of 5 plus e to the power of t plus a constant. Because this expression is positive, you may lose the absolute value and replace it with a parenthesis. Whereas this case, again, the first step is to simplify if you can. To do so, you have to factor the denominator. And I'm going to further tell you that even if you can factor it, has to have a factor of x plus 1 to be simplified. But in any event, uh, reminding you of the quadratic formula, ax squared plus bx plus c equal to 0, x is minus b plus minus a squared of b squared minus 4ac over 2a, and b squared minus 4ac plays a important part because it's the discriminant and it gives us a lot of information. When it's positive, we have two distinct real solutions. When it's 0, 1, which is a rational number. When it's negative, we have none. We have two complex solutions, a plus minus bi. If it's a perfect square, that means it can be factored out. So one way to look at this is to calculate the b squared minus 4ac. A is 1, b is 2, c is negative 1. So b squared minus 4 times a times c is positive 8, which is not a perfect square, can't be factored out. So u becomes the denominator. Its derivative is 2x plus 2, which may, or 2 times x plus 1, which makes du is 2 times x plus 1 dx. Move the dx up because it's parts of the numerator. So the bottom is du, but the numerator is not. The bottom is du, but the numerator is not du because number 2 is missing. Because it's a number, I can put 2 and it's reciprocal 1/2. So now I have 1/2 the integral of du over u looking like that. It's a natural law. And reverse substitution, 1/2 ln of x squared plus 2x minus 1 plus a constant is the final answer. Now, again, for this one, you can lose the absolute value and change it in the parentheses. This one you cannot because it can be positive or negative. Now, I want to look at the reciprocal of these two. First of all, this one, if you have the reciprocal, you have to use either long division or synthetic division to continue with the board. This one, you make up two fractions. This one, 5e to the power of negative t. This one is 1, and therefore there is no need for the substitution, and that's the key. Remember, the exponential, the answer is always itself in the case of a differentiation or integration. In this case, we divide by negative 1 becomes negative 5e to the power minus t. 1 gives you t plus a constant, and you're done. And that's the final answer.